So for today, we'll be doing some exercises on analyzing systems. But before that, does anyone have any questions or points of clarification regarding lecture one of module two? So same procedure, just raise your hand. We'll recognize that you have a question to ask and you can unmute and ask the question. Okay, so if no one has a question regarding lecture one, I have a question for you guys in your own words. Okay, so it could be a mix of Filipino, English in a simple way as possible. Can you kindly explain what the steady state assumption is? Okay, again, in your own words, what does the steady state assumption is in systems ecology? 10? Okay, Isa, go ahead.
Miss, in my own understanding, the total input is equal to the total output po.
Okay, thank you for that, Isa. Does anyone else want to have share their own definition? Say, go ahead.
The steady state assumption is the assumption that everything within a system is constant. Wala pong increase, wala pong decrease ng any input or output as was mentioned earlier.
Okay. Mai, how about you? What do you think?
Similar lang in a way that since it's also called dynamic equilibrium, there's that type of equality that maintains a type of homeostasis within the system. So if something were to change, it would depend on the other inputs and outputs if they would be affected too, just like the other scenarios in the lecture.
Okay. And Mariana?
Hi po. So just the same as the others that the steady state assumption would assume that any system maintains dynamic equilibrium or homeostasis. Homeostasis. So for that to happen, the input would be equal to the output, and the output would be.
Okay, so I hope everybody has that in mind as we go through some of our practice problems for today. But again, to reiterate what your classmates have shared with you, the steady state assumption is one of the most fundamental concepts of systems ecology. So we assume, again, this is an assumption, huh? So it doesn't mean it's perfectly true all the time. But we assume that an ecosystem maintains a dynamic equilibrium over time. Ano ang ibig sabihin nun? It means that while energy and materials are continuously flowing in and out of the system, the overall inputs and outputs remain balanced. So it's not exactly the same per se. Kasi when you say the same, parang kang vampire, no? You're frozen over time. It's balanced, no? There is an equilibrium, okay? So this results in a relatively stable condition. Now, in ecological models, the steady state assumption is very helpful kasi it simplifies the study of ecosystems by presuming that the key variables that we're studying, like population sizes, nutrient levels, yung pagbabago-bago ng energy, they do not undergo significant long-term changes even though tuloy-tuloy or ongoing yung internal processes within the system. So this assumption is particularly useful when we're analyzing nutrient cycling, food web dynamics, and ecosystem productivity. However, I would like to emphasize that real ecosystems rarely exist in perfect steady states. Kasi most ecosystems experience disturbances such as climate change, human activities, and also natural ecological succession. So eventually, siguro in higher systems ecology, um, there would be an integration of non-steady state models. So we actually have available algorithms that can introduce disturbances. But for now, we'll focus on analyzing systems, assuming that they are in dynamic equilibrium. So let's go through our first practice problem. So you have here a 6-compartment system. You have 6 pails, H, I, J, K, F, G. They represent the phosphorus cycle in a hypothetical seagrass beds. So if you look at the flow, so there's units. The flow from H to I and I to K is 0.5 phosphorus units per time. Compartment H to J and compartment J to K is 1 phosphorus unit per time. H to K, H to K is 14.5 phosphorus units per time. And basically for everything else, K to F, F to G, G to H, we have 16 phosphorus units per time. Now, this would stay as is for long periods, but what would happen to the nutrient level in compartment H? So just focus on compartment H. I'm not asking about I, J, K, F, and G. But what happens to the nutrient levels in compartment H if half of its contents is suddenly taken out of the system and everything else is not modified? So think of it as, let's say if the contents of each pail was your savings account, no? So let's say you're saving up on phosphorus, and then you are compartment H, and let's say half of your savings gets scammed, like somebody gets it from your ATM out of the blue. What would happen to the contents of compartment H? Would it go down? Would it go up? Would it be refilled again or go back to normal? So what would happen to it? So I'll give you maybe 2 to 3 minutes to analyze the system. And then I'll do my usual countdown to see who would like to recite. Okay? So again, try to think. If half of the contents of container H, compartment H, was taken out, what would happen to it after a while? Will it continue to go down? Will it continue to go up? Will it go back to its normal level? Will it just stay like that? Nangalahati na lang siya. Okay, so think, and then when you're ready, please raise your hand. But I'll give you 3 minutes instead of the usual 10 seconds. Okay, we have someone who's ready. Zaira, go ahead.
So based from my understanding po, I think that age, because of the situation, yung inflow ng H became higher than its outflow because nawala yung half. So when half of the H was removed, yung outflows niya became smaller. So the inflow from G stayed the same. So if the inflow is higher than the outflow, magsa-start to fill up ulit yung H at some point. And then after some time, H goes back to its original level before it was taken before half of it was taken away. So it will recover the nutrient level that it had before.
Okay, so Zaira says it will recover. Does anyone else have a different answer? Aika, go ahead.
My assumption was that we're not decreasing the amount of phosphorus that's going into H, but the amount of phosphorus that was in H just got completely halved. So because the amount of phosphorus that's going into H and the amount that's going out of H is still the same at 16 units per time, it's gonna still be in a steady state as the rest of the pails are also still in their steady state. So I think that H will just have that half amount of phosphorus, but it's going to remain constant.
Okay, thank you for that, Aika. So does anyone else have a different answer from Zaira and Aika? Carlos, go ahead.
Similarly to the last one, for me, I think it would stay um half indefinitely because um if you notice how much is being and how much is coming out, the outflow of H, it doesn't uh equal to that of the inflow. So I think it will stay half indefinitely po.
Okay, thank you for that, Carlos. So for those of you who are like, huh? How are they giving those answers? Where are those answers coming from? Well, when you're trying to analyze steady state systems, what you can do is to track the amount of nutrients coming in and the amount of nutrients coming out. So you can do that for each of the compartment in this system. So for example, for compartment K, you look at the nutrients coming in. So it's getting 0.5 from compartment I, it's getting 1 from compartment J, and it's getting 14.5 from compartment H. So it's receiving 16 units of phosphorus all the time, but it's also paying 16 units of phosphorus to the next compartment, which is compartment F. So in the case of compartment F, the analysis is a little simpler. It's getting 16 from compartment K, and it's giving out 16 to compartment G. As for compartment G, also straightforward, it's receiving 16 from compartment F and giving out 16 to compartment H. So for H, you might need to do a little bit more addition. It's receiving 16 units from compartment G, but it's giving out 14.5 to compartment H, 1 to compartment J, and 0.5 to compartment I. So all in all, you still have 16 and 16. For compartment I, it's receiving 0.5 from compartment H, and it's giving out 0.5 to compartment K. For J, it's receiving 1 from compartment H and giving out 1 to compartment K. So almost always you look at what's coming in and what's coming out to see if there's a balance. So if we're going to focus on compartment H, we cut in half its contents. So it's like your savings account, but it's still receiving 16 from compartment G all the time. But it's also giving out 16 to compartments I, J, and K. So technically, nothing has changed in what it's giving out and what it's receiving. So when we cut its surplus, its savings in half, it will just decrease or stay in its halfway state permanently because it is still in a steady state situation wherein what's coming in is equivalent to what's going out. Okay? So I'm not going to ask if that's clear right now. Sometimes it's really confusing, so I don't want to put any pressure on people to like, okay, gets again. That's why we have many practice problems prepared for today. So here's the next one. So it's still the same system, okay? But what's changed, okay, is what happens to the nutrient level in compartment H if this time, instead of cutting it in half, I double it. So, nanalo siya sa loto ng phosphorus. Biglang nag-dump tayo ng phosphorus from the phosphate CSO lottery. But everything else is not modified. So, I'll give you a few minutes to think about it. And then let's hear from people what they think would happen to the contents of compartment H. Will it increase permanently? Will it go back to normal after a while? Will it decrease because of that sudden increase? So try to think what would happen to the contents of compartment H if we increase the amount of phosphorus inside it, but nothing else is modified. Okay, we have a volunteer. Erin, go ahead.
Since it was mentioned po na the inputs and the outputs are still the same, I'm guessing po na the content in compartment H will stay the same, like it will remain at a doubled amount and it won't go back down or up po.
Okay, thank you for that, Erin. Does anyone else have a similar or different answer from Erin? Okay, people are probably still processing, but to help you, again, let's track what's going in and what's going out. So for K, it's still receiving 0.5 from I, 1 from J, 14 from 0.5 from H. So in total, it's still 16, and it's still giving out 16 to F. For F, it's receiving 16 from K and giving out another 16 to G. For G, it's receiving 16 from F, but it's also giving out 16 to H. And H, the one we're trying to look at, H is receiving 16 from G, but it's giving out 14.5 to K, 1 to J, and 0.5 to I. So all in all, 16 in and 16 out. For I, receiving 0.5, but giving out 0.5 to K. For J, receiving 1 from H, but giving out 1 to K. So again, going back to H, since when we double its contents, again, that's the surplus, that's the excess. But what's going into H and what's going out of H is still the same. So again, we are still in a state of dynamic equilibrium. Since what's going in and what's going out is equal, whatever is within the compartment, since that is your surplus, it won't change. And so, since we doubled it, the contents of compartment H would stay doubled because, again, what's going in and what's going out is still equal. So, hindi siya magbabago. Sige, let's try to make this a little different. This time, what happens to the nutrient level in compartment J. This time we're concerned about compartment J. If the flow from H to J is initially set to 0.5. So before it was 1, now it became 0.5. So what will happen to the nutrient level in compartment J? Okay, so I'll give you a few minutes to think about it. But yeah, what would happen to the nutrient levels in compartment J? Okay, go ahead, Troy.
Um, I I think the nutrient levels of compartment J decreases since there are less input than the output po.
Okay, will it decrease temporarily? Will it decrease permanently? And when we say decrease, will it just go
Uh,
down a little, or will it go down until it's almost empty?
um, I think it will decrease permanently po.
So it will stay fixed at a lower level. Will it go down to the point that J is almost empty, or parang mababawasan lang talaga siya ng konti, tas magsistay siya ng nabawasan ng konti?
It will go down po until almost empty po.
Okay, thank you so much for that, Troy. Does anyone have a similar or different answer to Troy? Nikki, go ahead.
For me, I think po, hindi naman po magiging almost empty si J kasi po it will still be supplied with um flow from H, so it can still remain uh still like half full, but it will also magde-decrease but not totally empty po.
So magde-decrease but not necessarily totally empty. Okay, thank you for that, Nikki. Okay, anybody else with an answer for J? Okay, sige. So i-analyze natin yung flow ng nutrients sa system ngayong nagbago na ang lahat. So the main difference is with the flow from H to J. Before, 1 unit siya, tapos naging 0.5. So kung titignan natin si K, it's still receiving 0.5 from I, it's still receiving 1 from J, it's still receiving 14.5 from H. So 16 pa rin yung nare-receive niya, and it's still giving out 16 to F. Si F, 16 yung nare-receive, 16 yung binibigay. Si G, 16 yung nare-receive, 16 yung binibigay. Si H, 16 yung nare-receive, pero nagbago na yung gini-give out niya. It's giving 0.5 to I, it's giving 0.5 to J, and it's giving 14.5 to K. So H is actually giving out less than what it's receiving. For I, it's still receiving and giving 0.5. For J, it's receiving 0.5 and it's giving out 1. So what does this imply? So like I mentioned earlier, the contents of each compartment is like your savings account. As long as you're receiving what you're giving, your savings account doesn't need to be touched. So for example, if you're receiving a salary of 1 and your rent is 1, then you don't have to touch your savings account. However, in this case, J is receiving only 0.5 in terms of, like, say, salary, but it has to pay 1 in terms of rent to K. So since the amount that it has to pay out is more than what it's receiving, then it will start to tap on the surplus. It will now start to tap into the savings. So every time J needs to pay K, which is all the time, it will now slowly deplete its surplus. It will now slowly deplete its savings. Kunyari, every month, kailangan magbayad ng rent, pero every month, 0.5 lang yung nare-receive niya kay H. So, lagi siyang nagpapalawal. Lagi siyang nagkukuha sa savings niya para mabayaran si K. Until eventually, dahil wala namang nagdadagdag sa savings niya, kasi laging kulang yung nare-receive niyang salary, mauubos yung savings niya. Ngayon, pag naubos ang savings ni J, hala, nasaid na siya. Kakayanin pa ba niyang magbayad ng 1 kay K? Again, pag naubos ang savings ni J, what would happen to the flow of nutrients to K? Okay, I'll give you a few moments to think about it. But again, once naubos ang savings ni J, what would happen to the flow of nutrients to K? Unfortunately, sa phosphorus system, guys, walang credit cards, ha? Tsaka walang loan sharks. So, si J ay hindi pwedeng mag-loan. Basta nakaka-receive lang siya ng 0.5 kay H, ubos na yung savings niya. Anong mangyayari sa flow of nutrients kay J to K? Karel, go ahead.
Miss, at some point po, ang kaya na lang ibigay ng J is 0.5. So, yun na lang po talaga yung ibibigay niya kay K. So, there would be a decrease po sa amount na nare-receive, sa total amount ng fluid na nare-receive ni K po.
Okay, thank you for that, Karel. So, once the surplus of phosphorus that's inside J has run out, it will still receive 0.5 from H, and then it will automatically give that 0.5 to K. Now, because K will only be receiving 0.5 from J, because J can't give anything anymore, this means that K will eventually end up only receiving 15.5. But it will still be paying F 16. So because of that, the surplus of K will also slowly run down. Mauubos din siya. Okay? Now, once all of the savings or all of the surplus phosphorus of K has run out, what will happen to the flow of nutrients to F? Okay, again, once all of the surplus phosphorus in K has run down because it's only receiving 15.5 but giving out 16 to F, what will happen to the flow of nutrients to F? So just like J, it's now receiving less than it's paying out. So what will happen to the flow of nutrients to F? Juliana, go ahead.
Eventually po, it'll also start to lessen, and then since it's giving towards since it's also providing towards ano po, towards G, it'll eventually lessen and run out din po.
Okay, thank you so much for that, Juliana. And good job on catching that pattern. So we started with J. J started receiving less than what it's giving out. So J depleted to the point of almost empty. But since it's still receiving 0.5, it can give 0.5 to K. K, because it's now receiving less than what it's giving out, K will eventually deplete until it's almost empty and just give out 15.5 to F. F will then start receiving less than what it's giving out. So F will go down to the point of almost empty, and then it will only give out 15.5 to G. So G this time will be the victim and start receiving less than what it's giving out. So eventually, G's surplus phosphorus will also deplete to almost empty, and it can only give 15.5 to H. But H is interesting because since the change of transmission from H to J, 1 to 0.5, what happened to H at that point? So let's ignore any changes from G at the moment. When H transitioned from giving 1 to 0.5 to J, what happened to its contents? No, nung binaba niya yung binibigay niyang amount kay J, did it stay the same? Did its surplus stay the same? Did its surplus go down? Did its surplus go up? Is it going up or down continuously? Or is it just going up a little at the start and then it stopped? So what happened to the contents in H when it started out giving less to J? Alexandria, go ahead. Alexandria, go ahead.
Miss, since that we see that the input from G to H is 16 and its output is 0.5 less, it'll the contents of H will slowly increase by 0.5, so there will be more surplus since its output is only 0.5 less.
Okay, thank you so much for that, Alexandria. You're right. So since it's receiving more than it's giving out, the savings or the surplus of H will slowly go up over time. Now, while it's slowly going up, the surplus of J, K, F, and G are slowly going down. Now, the moment that the surplus of G runs out, what happens to the contents of H? Will it start going down also? Will it stay at its higher level? Will it continue to go up? So again, once the surplus of compartment G runs out, what will now happen to the phosphorus levels of compartment H? Will it slowly go down also? Will it stay at its higher level? Or will it just go back to normal? What would happen? Kathy, go ahead.
Miss, I think it will go back to normal because initially what was it's giving is 15.5. So, nung nabawasan po yung G ng 0.5 na, kumbaga same na siya ng tinatanggap and ng nilalabas.
Okay, thank you for that, Kathy. So according to Kathy, dahil naging same na yung tinatanggap at nilalabas ni H, babalik na daw siya dun sa normal level. Does everyone agree with this or does anyone have a different answer from Kathy? Sige, let's put the situation in with, let's give another metaphor. So si H, kaya tumaas yung level niya kasi at one point, mas mababa yung kailangan niyang ibigay kay J, pero mataas yung nare-receive niya kay G. So dahil doon, nagkaroon siya ng savings. Kaso eventually, si G, bumaba na lang yung kaya niyang ibayad kay H. Dahil ba bumaba yung binayad ni G kay H, bababa na ba yung savings niya? Kasi equal na yung amount na binabayad niya sa amount na nare-receive niya? Or makikip pa rin niya yung savings na nakuha niya from before when mas mataas yung nare-receive niya sa nabibigay niya? So again, imagine, let's say at one point, the amount you're spending is less than the amount you're receiving. So you have your savings. And then all of a sudden, the amount you're receiving became less, but it's equal to the amount that you're spending. Will you have to touch your sudden bigger savings now that what you're receiving is equal to what you're spending? Bababa ba siya to its normal level? Or will it stay at a higher level? But hindi na siya dadami ulit. Anyone? Zaira, go ahead.
Miss, based on your analogy po, I think it will stay the same. Like H will keep its savings but it won't go up again because um yung although bumaba yung binibigay sa kanya ni G, hindi niya need spend hindi siya need mag-spend ng higher, so it will stay the same.
Okay, thank you so much for that, Zaira. You're right. So in this case, H, its phosphorus contents would go up while it's receiving high amounts from G while paying out less to J. But the moment G is paying it less because of how F wasn't able to pay him, K wasn't able to pay him, and J wasn't able to pay K, and so on, um, the amount that H is paying out will now be equivalent to what it's receiving. So it will stop getting more savings, but it doesn't mean that the savings that it had or it gotten before would be lost. So it will still have higher savings, but it will now stop earning more. So all in all, what would happen to this system is that the nutrient level in compartment J would decrease. Once it's run dry, the nutrient level in compartment K would decrease until it runs dry. And then the nutrient level in compartment F would decrease until it runs dry. And then the nutrient level in compartment G would decrease until it runs dry. And all this time, the nutrient level in compartment H would go up and then it will stay up and just stay as is. Now, while all of that is happening, is any change happening to compartment I? And why or why not? Okay, again, is compartment I changing? Yes or no? And why or why not? Dami ng kaganapan sa mundo, no? Pero anong nangyayari kay compartment I? Is it affected by any of all these changes that's happening to H, J, K, F, and G? Karel, go ahead.
I will not be affected po since nakapagbigay pa rin naman po ng 0.5 CH kay I, and the same way I can still give I can still give 0.5 to K pa rin po.
Thanks, Karel. I'm glad you are not affected. Joke lang. Kasi it's I. When I heard it, huh? Hindi daw ma-affectahan si Karel. But I realized, oh yeah, I. But anyway, sige. Yes, Karel is right. Compartment I will not be affected at all because as long as compartment H can give out 0.5 to compartment I, and as long as compartment I is giving out 0.5 to compartment K, I is oblivious to all of the changes that it's happening around it because it's still receiving what it needs to give out. Okay, let's have another situation. This time, the flow from compartment H to J shifted from 1 to 2. All of a sudden, H is giving out double to J. What happens to the nutrient level in compartment J if the flow from H to J is set from 1 to 2? Will it increase over time? Will it increase a little? Will it spill over? Will it not be affected? So what will happen to the nutrient level in compartment J over time? Okay, so I'll give you a few moments to think. Alexandria, go ahead.
Miss, if you can see the output required from J to K, it's still 1 phosphorus units per time. And since J is receiving twice the amount as that, it won't ever have like the opportunity to kind of distribute those extra units. So the content of J will increase over time.
Okay, thank you for that, Alexandria. But I have a follow-up for you. So it will increase over time, but will it spill over?
As long as the content required, I mean, yeah, the content required for K is 1 unit, it won't spill. I mean, I have a feeling if there's like a capacity for the actual bin, then yes, it's gonna spill over, but yeah.
So it might spill over. That's what you're saying.
It will spill over.
Okay, it will spill over. Thank you for that, Alexandria. Does everyone agree with Alexandria, or does anyone have a different answer? So it will increase, but will it spill over? So at this point, the simple answer of Alexandria is correct. It's gonna increase. The next thing I want everybody to analyze, and I'm not saying Alexandria is wrong. I'm just asking, do you think J will eventually spill over given it's now receiving double than what it has to pay out? And yes, the pails have a capacity. If you guys stay silent, I would assume you all agree with Alexandria that J will spill over. Final call? Everybody agrees J will spill over? Okay, let's see. So let's start with J again. So this time it's receiving 2 and paying out just 1. Since it's receiving 2 but paying out just 1, the contents of J will increase. Now let's look at what's happening to K. For K, it's still receiving 1 from J, it's receiving 0.5 from I, and 14.5 from H. So nothing is changing with K immediately. Still giving out 16 to F is still giving out 16 to G, and G is still giving out 16 to H. So nothing immediately happens to K, F, G, even though J is now receiving surplus. Our point of concern now is with H, because H is receiving 16, but H is giving out 17. Now, when H is giving out 17, despite receiving only 16, H will now start tapping onto its surplus. So once its surplus is gone, once its surplus is gone, will it still be able to give out 17 in total to I, J, and K? Again, when the surplus of H runs dry because of its current situation, will it still be able to give out a combined amount of 17 to I, J, and K? Mai, go ahead.
Now that we take H into consideration, it won't be able to supply for both I, J, and K. And at the same time, your last question with J, will it spill over? It won't be able, if we were just to think about its inflow, then technically, yes, it would be somewhat spilling over because there's more input rather than output. But in the case that H is not able to give its proper input towards J, it won't be able to spill over anymore because kulang nga yung savings ni H, so it won't be able to give anything. So it can't spill over anymore.
Thank you so much, Mai. So with that, we know that the nutrient level in J would increase over time while H still has savings. So increase, increase, increase. And while it's increasing, K, F, and G, nothing really happens to them. But H will eventually lose its savings. Now, once H loses its savings, it will no longer be able to give out 17 to I, J, and K. And so that will stop J from spilling over because it won't be receiving more than what it's giving out anymore. But at that point, once H loses all of its once H loses all of its savings, will J's level go back to normal or will it stay high? Again, once the savings or surplus of H is depleted, will the phosphorus levels in J stay high or will it go back to normal? So alam na natin hindi na siya magsa-spill over kasi mauubusan din ng savings si H. Pero pag naubusan na ng savings si H, will the savings of J be affected? So will it go back to normal or will it stay high? Come on, think about it. If H loses all of its savings, it's receiving 16 from G. What will happen to the savings of J that went up? Will it stay up or will it go down? Zaira, go ahead.
So although H lost all its savings, it's still receiving 16 from G. So yung nare-receive niya na yon, it can parang pupunta din po yun sa outflow ng H. So J will still be receiving from H, although it's not from H's savings na. J with this, J will stay at the same level. It won't increase or decrease. It will just stay the same, I think.
Okay, thank you so much for that, Zaira. So good analysis. You start by looking at the inputs and outputs of H. Since it's still receiving 16 from G, it can still put out 16. So it will probably distribute it to I, J, and K. And theoretically, it could retain giving out 0.5 to I, 14.5 to K. And although we've shifted from 1 to 2 for J, it's possible that it will shift back to 1. And if that's what happens, then the savings of J will stay the same. So tumaas siya kanina, it went up earlier, it will stay up, but it won't go up or it won't go down anymore. So we'll have, maybe if we have time, we'll have another practice question that will follow up on that. But let's go through another one. Okay. Click. Okay, this time, what happens? So we shifted, ito na pala yung follow-up. Magkasunod pala sila back to back. So if we shifted the flow of H to J from 1 to 2, what happens to the nutrient level in compartment I once the savings of compartment H runs dry? Okay, again, so i-reveal na natin to, kakapagkwentuhan pa lang natin eh. So kanina, we shifted the flow of nutrients from compartment H to compartment J from 1 to 2. And so far, our conclusion is that the nutrient level in compartment J will go up. It will not spill over because eventually compartment H will not be able to give it its increased amount because it's only receiving 16 from G. And therefore, eventually, once its surplus runs dry, it will only be able to give out 16 na lang din. But in that point, once the surplus of compartment H runs dry, what will happen to the nutrient level in compartment I? Will compartment I suffer once the nutrient levels in compartment H goes down? Okay, try to think about it. Angelina, go ahead.
I won't be directly affected po, so it would stay balanced. Since kapag po i-co-compute natin, kahit po wala po yung savings nung H, makakapagbigay pa rin siya ng 1 sa J tapos 14.5 sa K. So, masusupply niya pa rin po yung 0.5 sa I.
Okay. Mariana, go ahead.
Hello po, can you hear me?
Yes, I can.
Okay po. So, I think the nutrients in compartment I would remain the same because I guess one way to think about it is to see which of the compartments are demanding nutrients from H. So that's I, J, and K. So we've already figured out kanina that J would likely return back to its normal na 1. So between the next two, I and K, I think I would stay the same because it's demanding lower quantities than K. Because I don't know how to explain it, but like between a small and a large compartment, it's easier for the small to demand its quantity because it's smaller. So parang I would stay the same while K would suffer more if H were to.
Okay, thank you so much for that, Mariana. What Mariana is actually trying to describe, so both of your classmates are correct. But what I like about what Mariana was trying to say is she's actually describing what we call the proportional loss assumption. Now, when a system encounters deficits, there are two main rules that could apply. The first is the priority rule, which is not proportional, wherein one recipient gets its share first and others take the hit. So example, H might keep paying I its small amounts in full, which is 0.5, and then reduce only K's big share. In this case, K suffers first. Pero in priority rule, pwedeng ang priority ni H is si K. So if that's the case, pwedeng si I yung mag-suffer. But in nature, what we've noticed is walang ganung decision making. Kasi there's no like sentient creature who's saying, okay, this is what I would prioritize first. Instead, what we see is proportional loss. The shortage is distributed proportionally across all outflows. So that means every outflow can get reduced by the same fraction, but since I has a significantly lower amount, 0.5, than K, okay, I will be suffering the least, okay, or it's the last to suffer because it requires the least. And in the event that, let's say, G would have lesser inflow to H or lesser outflow to H, if H actually finds itself in a deficit, then it's actually likelier for K to suffer first than I or J. Okay, so that's what we call the proportional loss assumption. Okay, so thanks, Mariana, for giving us an explanation. Okay, let's move forward. Uh, so yeah, but I basically remains in its original level. Okay, this time we take out compartment H. And when we say we take it out, it doesn't mean, hala, nagkabutas yung system, all the phosphorus is leaking out. No. Just try to imagine a tube is now connected from G to I, J, and K. So again, we remove H. So basically, we remove all of its savings. And then all of a sudden, you just have a tube that's connecting G to I, J, and K. So which compartment will be the first to change if H is taken out of the system? So again, we remove the compartment, we replace it with tubes that distribute G's contents to I, J, and K, but its flow rate is relatively 16 in and it can release 16 out. So which compartment will change first? Aika, go ahead.
I don't think there's going to be like a first, second, third that's going to change in order because there's not going to be a change since the phosphorus outflow from G is 16. And now we're saying that from H, instead of it being a pail, there are now two beings going to K, J, and I. And the amount of inflow to that tubing is 16, and the outflow is also 16 units. That this is still in a dynamic equilibrium. Therefore, there's not going to be a change in the amount of phosphorus in the pails.
Okay. Does anyone have um a similar or different answer from Aika? So Aika says no compartment would change because there would be no change. So does anyone have a similar or different answer from Aika? Okay, with the silence, I'm assuming everybody has a similar answer to Aika. And if you look at the flow of nutrients from G to now I, J, and K. So if we look at G, that's the timer. G was receiving 16 from F, and it's capable of giving 16 out. So it's now just a matter of the tube distributing the 16 to I, J, and K. And since I needs 0.5, J needs 1, and K needs 14.5, and that is all equivalent to 16, G is capable of supplying the needs of I, J, and K. And because of that, there would actually be no changes, no immediate changes, because G can supply everything that is needed by I, J, and K, even if H wasn't in the picture. Okay, what if instead of H, it's G that we replace with tubing? So which compartment will be the first to change if we replace G with tubing? So we remove its savings, we remove the container, we replace it with tubes. So now F flows directly to H. Which compartment will be the first to change? Go ahead, Kirill.
Same lang din po as earlier. As long as G receives 16 from F, it will be able to give 16 po to H.
But is it G that's now giving out? So what's going to happen if you remove G?
It will be from F po
To?
to H.
Okay. So as long as H is receiving 16 from F and giving out 16 to I, J, and K, then nothing will change. And so in the system, if we replace G with tubing, so we remove all of its savings, we replace it with a tube, nothing will change. Okay. So good. Good practice, everyone. You can expect a lot of questions like this in our exam, in our second long exam, and in our quizzes. So it would be good to review this recording later on if some of you are still confused on how to analyze systems like this. But once again, um, for this coming Thursday on October 2, we will be having your long exam for Module 1. And then on Monday next week, October 6, we will be discussing hopefully lectures 1 and 2 if you have any questions about it. But basically, quiz 1 is dependent on you having watched lectures 1 and 2. Okay? So I hope you can prepare for those upcoming assessments. But before we close today's session, any questions or points of clarification regarding our lessons for today and also the lecture 1 video? Okay, if none, any announcements from our lab faculty?
Hi, good morning, everyone. Can you hear me, Doc Chana?
Yes, Sir Lau, we can hear you.
Okay, for the two laboratory classes later, let's meet at Miss Hillary's room for some announcements regarding what's going to happen for this week. So let's do it in plenary, Miss Hillary Orario's Zoom room. Thank you.
Okay, thank you so much for that announcement. And with that, we close today's session of ecology. Um, I hope after your long exam on Thursday, you do not forget the lessons from Hurlburt, because again, all of these will connect to each other. So wag niyo po siyang kakalimutan just because we're slightly looking at applications now. Okay, we might not be actively talking about experimental design in lecture, but trust me, it will still apply. Okay? So thank you so much, everybody. See you on Thursday for our first long exam. Stay safe, everybody. Bye-bye.
Bye, Miss. Thank you.
Bye.